So in this video, we're going to talk about layout low distance scores. And layout low distance scores are a way to evaluate the strength of different layouts, considering proximity requirements based on the interaction between units in the layout. So what you're trying to do is come up with something that minimizes the amount that people have to travel between units. So in this case, we're just going to do a linear one. There are 4 units, A, B, C, D, and we want to figure out if that is the best layout we can. So in that circumstance, we need the information on the trips, and this is something you'd measure or something, but in this circumstance we're giving it to you. So from A to B, it's 4, A to C is 10, A to D is 10, B to A is 6, C to A is 10, D to A is 20, B to C is 7, B to D is 5, C to D is 15, C to B is 8, D to B is 5, D to C is 5. So in that circumstance, what we normally do is we put it in a distance matrix. And we're not worried, obviously, about trips, internal trips, because that doesn't matter as to where it's, so the diagonal as to where it's located. And then so A to B was 4, A to C was 10, A to D was 10, B to A was 6, C to A was 10, D to, oh, sorry, 6, C to A, or B to C is 7, B to D is 5, C to A is 10, C to B is 8, and so we just fill it in like that. Now, we're not terribly worried about the direction that we have to travel in. We're just worried about the overall number of trips. So in that circumstance, we then still have zeros on the diagonal, but we're not worried about this half. We take B to A is 6, A to B is 4, so we put 10 here. C to A is 10, A to C is 10, so we put 20 here. And then we would fill it up similarly. And we have, this is then all of the trips between A and B. This is all of the trips between C and D. This is all of the trips between A and D. We're not worried about the direction. So what we need to do though is figure out the distance. And if we go back to our layout here, and we do our distances, adjacent departments are 0. Now, really they are 1, but it makes our lives a little bit easier when there are zeros in terms of the math. 2 rooms apart, 2. So A to C is 2, 1, 2. 3 rooms apart is 3, and so on. If you have a nonlinear A to B would be 0, D to E would be 0, A to C would be 2, and here A to F is 1, 2, 3. So you do it as right angles. So that's how you figure out the distance. And then you simply calculate the layout load distance score. So for the layout A, B, C, D, the load distance score is AB equals 10 times 0 equals 0. So if you did ones, you would just get a bigger number, but the relative performance wouldn't change. So that's why I do zeros here. A to C is equal to 20 times 2 equals 40. AD equals 30 times 3 equals 90. BC equals 15 times 0 equals 0. BD equals 10 times 2 equals 20. And CD equals 20 times 0 equals 0. So our total here is 150. That is our load distance score, is 150. Now, then we could take a look at an alternate layout. If we go back to this, we know distance times trips gives us our load distance score. So we probably, if we wanted to do something better, we would probably take a look at A and D being close together because they were far apart and that gave us a big distance. And A and C should also be close together, and ideally C and D. So there's no perfect way of doing this. You can sort of try different things. We want A and B to be close together, A and D to be close together, and we want C and D to be close together, but A and D are the priority. So let's do B, C, A, D. And now our load distance score is equal to AB, the 10 trips, but now the distance is 2. AC, 20 times 0, so those are close together, and so that's 0. AD, BD equals 10 times 3 equals 30, so they're further apart, but it's fewer trips. BC is equal to 15 times 0, so it's good, those are close together. And CD is equal to 20 times 2 equals 40. Our load distance score for this new layout is now 90. A lower load distance score is better than a higher load distance score, so in this circumstance, this layout is better. So this is a relatively straightforward concept, whether it's linear or in 2 dimensions. You look at the distances. As I said, I do adjacents at 0. I think that's the right thing to do, and it makes this math a little easier. You look at the number of trips. You're indifferent about the trips in either direction. And then you multiply distance times trips to get a load distance score. If you're asked to do a new layout, you would look at the number of trips that you have between them. That is something you can't control. You can control where you put them, and then you put the things with the biggest number of trips closer together. So that's a quick introduction to layout load distance scores.